in chat, go ahead and write the coordinate, the answer to this. Everyone in chat, go ahead and write the answer. Is it really a problem? Yeah, it's really a problem. So it's like, yeah, so like on your quiz, you're going to have one like this. So -1/2, comma, -3 radical 2. I'm sorry. Hold on. It's not what it said. It's scrolling too fast. Hang on. I missed it. Whatever.
What I meant to say was negative half as the x, and then it's negative radical 3/2.
That sounds pretty good. So which quadrant is that in? So what quadrant is this in,
I
guys?
believe that would be third, or yeah, 3.
Everyone agree with that? The third quadrant? Yes, it is the third quadrant. So positive 2 pi over 3 would be 120 degrees. So we're just going backwards 120 degrees, and that puts us right here, I think. Is that right, Antonio?
That is correct.
Yep. So this is the coordinates of -2 pi over 3. Nicely done. And then I typed it out so everyone can see it who's watching the recording if they just want to make sure they're right. And again, that negative can go in the numerator. That's where I like it. But your online test, whenever you enter numbers, they like the negative out in front of the fraction or it won't grade it correctly. Just how it is. All right. So yeah, you're going to have one of these on your quiz today. So I think I told some people yes or Friday and some through Skype. I'm pushing the lessons. So this was the lesson we're supposed to have on Friday, but we're having it today. And then we were going to have the review for the test today and the test tomorrow. But we're going to do the review tomorrow and the test in the same day, which is not really a big deal because we did that, I think, every unit last term anyway. So basically, last lesson today, review tomorrow, and test tomorrow. There you go. All right, so this is 2.05, day 2. We are going to evaluate trig expressions. So this is pretty much the same thing we did on Thursday, but maybe with plus and minus signs. All right, this is pretty much a disclaimer. When using the unit circle, we can only use 0, 30, 45, 60, and 90 degrees, those increments, to do the exact values, because we shouldn't have to type anything in your calculators. In fact, I don't want you to. Everything that we do on Thursday's lesson and today uses the unit circle. That's why you should have it in front of you, printed out. For today's lesson, I do have it on every single page that we need it, just for convenience. And in terms of memorizing, I talked about this on Thursday. I don't expect you guys to memorize this. I used to require students who I taught in person, who showed up for the test in person. They were required to memorize it, but I'm not having you guys do that, mostly because I can't enforce it. I don't think it's entirely fair that if I tell you guys to memorize it and don't use a test, that I do 100% believe that many of you will do that, but I do also believe that a large portion of you will just have it in front of you. So everyone can use it. There is a pattern to it, by the way. There is an easy pattern. All right. Yeah, so that pattern right here, all you got to do is memorize quadrant 1. If you know quadrant 1, you can memorize everything because these are just a reflection, right? So like this x value is radical 3/2. Well, this is negative radical 3/2. The y value is positive half. Well, it's positive 1/2. So these are just reflections going from quadrant 1, 2, 3, and 4. And then looking at this, it goes in the numerator for the y value 1, 2, and 3. And you have radicals. Well, radical 1 is still 1. Radical 2 is radical 2. Radical 3 is radical 3. So, that pattern's pretty easy. In the denominator, everything is always divided by 2. So that's also really easy to memorize. And then for the numerators for the x values, it starts over here, goes 1, 2, and 3. Radical 1, radical 2, radical 3. So the pattern is really simple. It would take you only 5 minutes to memorize it if you really sat down and tried. So like for I think your SATs, I don't think you have to do a whole lot of trig on your SATs. I don't remember. It's been a while. Okay, so also review from Thursday. So remember, your sign for the unit circle, your radius is always 1. So your sine is the y value, the cosine is your x value, tangent is, just like slope, y divided by x. So again, sine is y, cosine is x, tangent is y over x. That is super important to remember. And then your cosecant, secant, and cotangent, these are just inverses. So sine and cosecant inverse, cosine and secant, and tangent and cotangent. So your sine is 1 over y, secant is 1 over x, and then cotangent is x over y. So this is pretty simple also from Thursday. I don't recall if we did we do cosecant, secant, and cotangent on Thursday? We did. We did? Okay. I already forgot. Again, the radius is for a unit circle is always 1. Makes it really easy. Okay, some simple ones. I'll give you a moment to write these examples down. And let's everyone do the first two. I'll give you all a minute. By the way, I have a total of 10 examples today, so it's a pretty quick lesson. Most of this lesson is pretty much review from Thursday, so good practice. So a minute. Yeah, the only new thing we're doing today is we're going to have on the next page, we're going to have plus and minus in there and maybe some multiplication. Everyone do the first two, give you a minute. If you finish the first two within a minute, which you probably should, go ahead and go on to number 3. Yep. Yeah, so just like Thursday, I'm giving you the degree, the radian, not the degree, this is the radian. So the cosine of this angle, remember cosine is what variable again? And it's x. So the answer to number 1 should be the x coordinate of that radian value. All right, everyone in chat, go ahead and put the answer to number 1. 1/2. Looks like lots of 1/2s. Let's see, it probably is a half. I think it is a half. So we just go over to 5 pi over 3. 5 pi over 3 is right here, 5 pi over 3. 5 pi over 3 is 300 degrees. So we just look at the x coordinate is 1/2. You can also type in cosine of 5 pi over 3. As long as you're in radian mode, hit enter, you will get 1/2. So it's a way to check, but it's very important that you are able to use this unit circle to determine that value. All right, number 2, what's the answer? Again, this is weird. Not a half. I typed it wrong. Maybe I typed it wrong. Let's take a look. 5 pi over 6. So 5 pi over 6 is right here. 5 pi over 6. And this is the sine. I have no idea how I got negative radical 3 over 2 from 5 pi over 6. because it is clear that the y value is a half. So I don't know what I'm doing. I'm just checking to make sure all of you know what's going on. Yes, it is 1/2. 1/2. Everyone. Yeah, PowerPoint. Before I forget. 1/2. All right. All right. Number 3. Do you all need more time for that one? It's like some people put negative radical 2. Let's see what the final answer is. Radical 2. I get the right pointer out. Negative radical 2. It is negative radical 2. What? What did the rest of you get? Maybe you just didn't finish the problem. So negative radical 2 divided by 2. Let's take a look and see why some people got that. I thought the opposite of secant was cosine. Yep. Cosine and secant are inverses of each other. Yep, you are right. Looks like we got a lot of negative radical 2s. So let's kind of see. Maybe it was a simple mistake some of you made to get that that fraction in there. Let's take a look. So secant and cosine are inverses, so it's 1 divided by, it's 1 divided by the cosine, and cosine is x. So we want the x coordinates at negative 3 pi over 4. So let's look at negative 3 pi. Well, 3 pi over 4 is 135 degrees, but where it's negative, so rather than go positive, we want to go negative. So we're going a negative 135 degrees. So that puts us right over here. So this is negative 135 degrees, or negative 3 pi over 4. And the x value here is negative radical 2 over 2. So it's 1 over the x value. Everyone's good on the setup, right? So the hard part was doing the math to kind of simplify it, right? Yep, reflecting it also. So would that always work if you reflected it? Yeah, that should work. Yeah, that would work. All right. So when you have a fraction divided by a fraction, we have to flip and multiply. So it should be 1 times negative 2 over radical 2. Did everyone have this step done? And most of you with calculators can just type it in, hit enter, and get the answer. So that works too, but I'm going to show you. I think it's important to understand mathematically what's going on. I think it makes you smarter overall. All right, so 1 times anything is itself, so we just get negative 2 over radical 2. Remember, we are not allowed to have radicals in our denominator. So what do we have to do? Rationalize. So multiply by radical 2 over radical 2. Yep. We must rationalize. So I have that in blue. So I'm multiplying it by 1. So the numerator gives us -2 radical 2. And the square root of 2 times square root of 2 is the square root of 4. And the square root of 4 gives us 2. And then we have this 2 and this 2 cancel out. And that leaves us with negative radical 2. For those of you who had the fraction, the 2 and the denominator, did you find your mistake? All right, what was your mistake? I'm just curious. So just didn't simplify? Okay. Just that very last part. Okay, Antonio. That's probably true. Um, yeah, I guess it can make you a little smarter. Find hacks to make it work. All right, number four and five. So number five, if you notice, is these are parts from 1 through 4 kind of put together. So keep that in mind. You don't have to resolve these parts. You're just going to basically replace this with, well, the answers you got. There's no point of doing the work again. Oh, I have something to say about that, Antonio, but I'm not going to. All right, we'll give you, say, 2 minutes for 4 and 5. 2 minutes. Hmm. Got another 48 seconds left. We need a pi answer for 5. No, I don't think so. You may have radicals in your answer. Most likely have radicals in your answer. Right. Answer for number 4 in chat. 1. That was easy. If it's right. Why is it 1? Maybe want to explain on mic why it's 1? Go for it, Julia.
Okay, so it's asking us the cotangent of pi over 4, and we know that tangent is sine over cosine, and we have rad 2 over 2 divided by rad 2 over 2, and a number divided by itself is always 1. And now cotangent is 1 over tangent, so you have 1 over 1, which simplifies to just 1.
That sounds perfect. I couldn't have said it better myself. Good job. Yeah. And there's the work. Remember, cotangent is not, well, yes, it is 1 over tangent, but it's also y or x over y. Let me go back to that page. So yes, cotangent is 1 over tangent, but in terms of using the unit circle, it's x over y. But both work. But this would probably be the easier way to go about it. That, I think, was a motorcycle, I think. Somebody driving up and down the street, I don't know. I think it was a quad. I have no idea. Yep, so that is 1. Yep. Okay, so number 5. You're just filling in the stuff that we've already calculated. We got 2 times the cotangent of pi over 4, so we know that's 1. So 2 times 1 plus the sine of 5 pi over 6. We know that to be negative radical 3 over 2. Unless I made a mistake on the previous page. Yeah, I did. Yep. This whole problem is wrong. All right. What did we say that was? 1/2? Yep. So we got 2 times 1 plus a half. Well, that's 2 plus a half. So that's going to be 4 halves plus 1 half is 5 halves. All right, everyone get 5 halves? All right, answer is 5 over 2. So we're not going to look at what I have for the work because my work is wrong. 5 halves. Five over 2. Now let's pretend that my setup wasn't wrong. Let's pretend. Let's pretend that's what it was. Here's the work for it if it was the right work. So it would become 4 minus radical 3 over 2. That's if the work was actually correct for the problem we were doing, but it's not. Me too, Sarah. Me too. Right. Number 6. I'm going to give you all, I'll say 2 minutes for number 6. If you finish number 6, go on to 7 and 8. But number 6 has some work to it. 2 minutes. All right, 2 minutes is up. All right, anybody have an answer for number 6? It's like negative radical 3 over 3. Anybody else? All right, same thing for a few other people. All right. So how did you, so let's, anybody want to volunteer of how they started this problem, given the tangent of negative 37 pi over 6? How did you use this? Because we obviously don't have this on the unit circle. So what did you do? Emily, go for it. Try to explain.
I typed it on a calculator.
Yep, that's the wrong way to do it. Anybody else? Because I want to use a unit circle. Found the coterminal. So how'd you find the coterminal, Katie? So converted to degrees and then added 360 until you got positive. That way perfectly works. Yep. Yep. So I know I don't like working with radians, not so much usually. So converting it into degrees by multiplying by 180 over pi, and then keep adding 360 to it until it becomes positive, and then you get your coterminal degree. Yep, that totally works. All right. So I like the way that you did it. Another way to do it is making it into a mixed fraction. So mixed fractions, they have their place. Giving your final answer on a test, a mixed fraction, is never allowed. I would say almost never allowed in this course. I say almost never because there's always some exception. I just can't think of one right now, but there probably is. Some people turned in part 2 of their Unit 1 exam, and they gave me mixed numbers. And I was just confused because I don't want those ever, usually. But in this case, it's very helpful to look at. So Negative 37 over 6 is negative 6 and 1/6. Well, so we have negative 6. Now remember, 2 pi is a full rotation. So this is going to be 2, 4, 6. So we have 3 full rotations going clockwise. So we have 3 full rotations and then 1/6 pi left over. And 1/6 pi is just 30 degrees. So that puts us at 11 pi over 6. So that is another way to approach it. Into a mixed number like this. All right. And then once you have those values, tangent is y over the x. So that is why we have negative 1/2 over radical 3 over 2. So far, so good, everyone? See, there's some discussion going on. All right. So once we have that set up, the math should be pretty simple. We flip and multiply the denominator. And that's how we get negative 2 over 2 radical 3. Also, in this step, going from this step to here, I could have canceled out the 2 and 2. And then that would have saved me a step of what I'm going to show next. So you could just have negative 1 over radical 3 in this step here. And then we have to rationalize it. But you want to cross this out, the 2 and 2. And then that's how we're going to get negative radical 3 over radical 9. And again, I am showing a lot of steps. I think everyone in this class should go from seeing radical 3 times radical 3 is radical 9. The square root of 9 is 3. So you probably should just had a 3 here and not shown this extra step. I'm doing it just for some people that probably want to see it. And then that's how we get that answer there. So nice job, everyone who got the same answer. All right. Let's give you about one more minute to finish 7 and 8. And I believe probably a lot of you are already done with those 2, but I'll give you 1 more minute to finish up 7 and 8. Yes, this is what we did on Thursday. The new piece would be like number 10 on this page, where we're gonna have multiplication and addition. So like number 10 and number 5 are the new pieces. We just put stuff together to make problems seem more complicated than they really are. All right, what is the answer for number 7? Radical 3 over 2? Rad 3 over 2, rad 3 over 2, rad 3 over 2s. See if I typed it right. I did. Yep. About number 8. What is that final answer? So I got a couple answers here. We got 2 radical 3 over 3. We also have negative 2. So rad 3 over 2 seems pretty popular. Anybody else? Remember, it's okay to be wrong, guys. It's also great when everyone's wrong at the same time. It's a great learning moment. So we got some more negative twos. So we seem pretty, it looks like split between -2 and radical 3 over 2. And we got 2 radical 3 over 2. So we got maybe like 3 different answers. We got -2. Let's take a look. Let's see what I got. I did get -2. Maybe I'm wrong. I've been wrong twice so far today. All right. So cosecant is sine. So it's 1 divided by sine. So, or in other words, 1 divided by y value. So we should find the coordinate and we should write 1 divided by the y value. All right, let's take a look. So -5 pi over 6. Pointer out. Well, 5 pi over 6 is 150 degrees. So -5 pi over 6 is going to be -150 degrees. So that puts us right here. So we should be looking at this coordinate right here. And we want the y value, right? So it's 1 divided by this y value, -1/2. And then we flip and multiply. So we take the denominator, we flip it, and multiply it by 1. So we got 1 times -2 over 1, which is just, well, -2. So the mistake, it looks like, did we grab the wrong coordinate? Did you grab the x value instead of the y value? Is that what happened? So Sarah, yeah, so Sarah grabbed the wrong value. Okay. Emily, what did you do? Oh, yeah, don't type these in. What are you doing? All right. All right, this page is good. These 3 problems, we good to go on? Yeah, it's funny you say that. My mom's side of the family, they're all from New York and they have very strong New York accents. All right, 9 and 10. Cosecant of pi. All right, so let's do 2 minutes for these 2 problems. 2 minutes. All right. Time is up. Number 9. Number 9 is undefined. Yeah. 9 is undefined. And so all of you discover is because, well, you can't divide by 0. That's not allowed. Yep. Undefined. All right. Number 10. What did y'all get for number 10? Do you need more time for number 10, guys? All right. So, give you a little hint. Number 10. We already figured out all of 3 of these values on the previous page. So, you shouldn't be solving them again. You should just be plugging them back in the answers to these 3 problems to do the math. So, I'll give you a minute to finish that problem up. How about that? 1 minute. All right. 1 minute starting now. Ready, go. All right, time's up. All right, what is our answer for number 10? -5/2. Question mark? Caitlin, what'd you get? So I'm pretty confident -5/2 is not correct. Radical 3 minus radical 3. Hold on. All over 3. Negative. So Chloe got -4 radical 3 over 3. I think Chloe might be right. Negative 4 radical 3 over 3. Jacob got the same thing. Yeah, so I think it's negative 4 radical 3 over 3. Negative radical 3 minus radical 3 over 3. So, Dianica, yours may not be simplified yet. All right, so Dianica, yours needs to be simplified. So take that first negative radical 3, multiply it by 3 over 3 to get the same denominator, and then combine like terms for numerator, and you should have the same answer. So yeah. Yeah, negative radical 3 minus radical 3 over 3, that simplifies into a single fraction. And that's important to do. So let's take a look. So yeah, the final answer is negative 4 radical 3 over 3. Let's take a look. So we took all the stuff from previous page and we just plugged those answers in because we already did the work. All right, so that first term, radical 3 over 2 times negative 2, becomes negative radical 3. Oh, I should have had that in blue. So this part should be in blue because I need to get it to be the same. This is the part I told you, Danica and the rest of you who stopped at this step here, and you had negative radical 3 plus or minus radical 3 over 3. We got to multiply this first term by 3 over 3 to get it to have the same denominator. Then it looks like this for the second step here. And once these are the same, we can now combine like terms in the numerator. So we have negative 3 radical 3 plus negative radical 3. Well, these radicals are the same. So it's like saying negative 3x plus negative 1x. It's kind of the same idea. So I have negative 3 of these plus negative 1 of these. Well, negative 3 plus negative 1 is negative 4. But before I do that, I wrote them all together so it's easier to see. And then I made it just a single fraction here. Negative 3 minus 1 is negative 4. You may want to Google adding and subtracting radicals if you need a refresher on how those work. All right, so in conclusion, so the part that was new was the whole adding and subtracting part, like on number 10 and number 5. So what you want to do for these is do the work individually. Don't try to do them all together at once. You want to do them all separately, get the answers for all, in this case, all 3 of these. And then once you have the answers, then you just drop those answers in and then do that math. So it'd be too complicated to try to combine all of this work in a single problem. So do them separately, then drop them in. It'll make the math seem easier. All right, any questions on today's lesson? All right, well, guys, I hope you learned something, and I will see you all tomorrow for the review.